all the problems which we have seen up till now in statics, they were talking about only the two dimensions, but in reality the forces will not be applied in a particular plane. That means it is not going to be a two-dimensional problem every time. We have considered all the 2D features with respect to the assumption that they can be extended further for the real-time applications where the forces will be acting in the 3 dimensions, and they could be making some angles with horizontal, vertical, as well as there could be one more direction which could be treated as the depth. So now let us go ahead and apply these principles to a few problems which are related to the equilibrium in 3D. Also that we are required to find the moment of the force in 3D. So we will be now switching over to the problems where we will be given the coordinate system, which is a 3-dimensional coordinate system. So we might be having x-axis, y-axis, z-axis, and to specify the problem they might give us some 2 points, either in one form or another. We will be given 2 points in which the force is acting. So force AB bar is acting along line AB, and if coordinates of point A are x1, y1, z1, and that of point B are x2, y2, z2, this is origin, and magnitude of force is say F, then force AB is to be found out. Now as we have seen in 2D that the force is going to have the magnitude as well as the direction. Now if we are to write the direction in 3D, then it is not possible that we could be writing the direction as making some angle, because which angle we are going to specify. So here we will be writing it as the angle with x-axis, y-axis and z-axis, respectively known as theta x, theta y and theta z, or we could be writing it as a vector. So let us see the vector approach for it. Vector AB bar is to be written. So that will specify the direction. Vector by itself comprises of magnitude as well as direction. Let us revise a few features of vectors. Some vector P bar, which is written as P1I plus P2Z plus P3K, where I, Z and K are unit vectors along x, y and z axis respectively. Now when we say that it is a unit vector means magnitude is 1. So we can simply show the system in this manner. So this will be unit vector along x-axis, so this will be unit vector along y-axis, and this will be unit vector along z-axis. Now any point that we talk of in 3D, any point, the coordinates that we talk of, suppose this is point x, y, z, say point P, and if we write the vector OP bar, then remember that these coordinates are nothing but the distances. So this is the distance travelled along x-axis, distance travelled along y-axis, this is our y-axis, and distance travelled along z-axis. So ultimately this is the direction in which the movement will take place, and to indicate that it is direction x-axis, we will write it as xi plus yj plus zk. That is what we call it as the vector addition. And so OP bar which can be simply written as position vector of point P. It will be xi plus yj plus zk. Now magnitude of the vector is nothing but under root coefficient of I square plus coefficient of j square plus coefficient of k square. So this will be the formula by which we can find out unit vector or the magnitude of the vector OP bar, and unit vector OP bar can be written as vector OP bar divided by magnitude of OP bar. Unit vector means it's the vector having magnitude 1 but direction same as that of OP bar. Now these are the simple basics which we will be requiring for solving any problem in 3D. Also the fact remains that once we have got this particular formulation, then sometimes we are required to even write down as what are the angles made with x-axis, y-axis or z-axis. Now for that, in mathematics we must have studied something called as direction ratios or direction cosines. So if this is OP, then this will be angle made by OP with x-axis, say theta x. There could be angle made by OP with y-axis as theta y, and angle made by OP with z-axis as theta z. And so unit vector along OP can simply be written as cos theta xi plus cos theta y j plus cos theta z k. But we have just now written that OP cap can also be written as xi plus yj plus zk upon under root of x square plus y square plus z square. And so just by comparing these two, we will get cos theta x to be equal to x upon under root x square plus y square plus z square, cos theta y as y upon under root x square plus y square plus z square, and cos theta z is equal to z upon under root x square plus y square plus z square. So from unit vector it is possible that we can find out the angles or the cosine of the angles made by the particular vector with x-axis, y-axis and z-axis. These are actually called as the direction cosines. Direction cosines. In short, DCs we say. Whereas x, y, z, they will be known as the direction ratios, and we can always relate the direction cosines with direction ratios. So this is the background of vectors which we will be requiring when we actually solve the problems in 3D. Going back to our earlier example, where I have a vector AB bar and force is acting along it. Now if I just connect point A to point O and point B to point O, then you will find that this is forming a triangle. You will find that OA bar plus AB bar is actually OB bar. We find that OA bar plus AB bar is nothing but OB bar, and therefore AB bar can be written as OB bar minus OA bar, and any vector, any point when it is connected to origin, the vector that we get like OB bar, OA bar, OP bar, these are called as the position vectors, and they can be written by the small letters B bar minus A bar. Whereas B bar in this case will be x2i plus y2j plus z2k, and A bar will be x1i plus y1j plus z1k. So as we want to find force AB bar, F bar AB, then the stepwise it will be find out first AB bar, and AB bar will be found as B bar minus A bar. So it will be X2I plus Y2Z plus Z2K minus X1I plus Y1Z plus Z1K. So it will be the respective direction subtraction. It will be X2 minus X1I plus Y2 minus Y1Z plus Z2 minus Z1K. Then we find AB cap, which will be AB bar upon mod of AB bar, which will be X2 minus X1I plus Y2 minus Y1Z plus Z2 minus Z1K upon under root X2 minus X1 bracket square plus Y2 minus Y1 bracket square plus Z2 minus Z1 bracket square. And therefore FAB bar will be written as magnitude of the vector into unit vector in that direction. So in this case FAB bar will be written as the magnitude of the force is given to us as F into the vector AB cap, and so the force can be expressed in the vector form. So the force can be expressed in the vector notation form, and which is a complete representation of that particular force. We can determine the magnitude also, and we can determine the angles made with XYZ axis if they are asked in the particular problem. So when we think of problems in 3D, we will be first of all going for finding the coordinates of different points in that particular given figure, and then we will be locating the starting point and ending point of every direction along which the force is acting. Once the directions are determined, then individual vectors are to be found, and then from those vectors we will go for finding the unit vectors. We will multiply by the magnitude, and we will get the vectors in the 3D notation, that is the vector form. Those forces will be obtained in the vector notation form, and then we will apply our standard rules of equilibrium. Let us consider a problem, a simple problem, say. We are given a block, a rectangular block, say like this. So O, A, B, C, when the points are named, the distances are given to us as OA distance is given to us as 30. We are given height as 45, and the width of this block as 70. So the dimensions are given to us, and we are given a few forces which are acting, like there is a force acting in this direction of some 100 newtons. Then we are given a force which is acting in direction DG bar of 150 newtons. We even have a force acting from O towards G of 200 newtons. So these are the forces which are given to us, and we are required to find resultant force at G. This is the case of concurrent forces, and we are required to express each of the force in the vector form, in the vector notation. So the procedure is going to be a simple and straightforward one. We are going to consider the resultant R bar, which is going to be F BG bar. Here the names are important, it is from B to G, plus F OG bar plus F DG bar. So three vectors are to be found out, and for that let us write down the coordinates. Now the axes are generally standard, but we should be always having a look at where is x-axis, y-axis and z-axis. So coordinates of point A in this case will be 30, and it is on x-axis, so y and z are 0. So for A, coordinates are 30, 0, 0. For B, x coordinate remains 30 and y coordinate becomes 70. So it is 30, 70, 0. Actually OA, BC are all the points having z equal to 0. C point is on y-axis, its coordinates will be 0, 70, 0. Now this being a rectangular prism, we will simply shift z coordinate to the height, that is 45, and coordinates of D will be 0, 0, 45, because coordinates of O were 0, 0, 0. Coordinates of A are 30, 0, 0, so coordinates of E will be 30, 0, 45. Coordinates of B are 30, 70, 0, coordinates of G will be 30, 70, 45. And coordinates of H similarly will be 0, 70, 45. This is how we can write all the coordinates. Origin is of course 0, 0, 0. So let us find FBG bar. FBG bar is to be found out. So let us find out BG bar, which will be simply G bar minus B bar. Now coordinates of G are 30I plus 70Z plus 45K, minus that of B are 30I plus 70Z plus 0K, and so after subtraction it simply remains 45K. Therefore BG cap, that is unit vector along BG, will be 45K upon magnitude, which will be 45. So BG cap comes out to be K. Actually we wouldn't have calculated all this. We can clearly see that 100 newtons force is along positive Z direction, and therefore FBG bar comes out to be magnitude, that is 100 into BG cap, that is 100K. To determine FOG bar, it will be OG bar that is to be found out, and OG bar is simply G bar, which will be 30I plus 70Z plus 45K. Therefore OG cap will be 30I plus 70Z plus 45K upon under root of 30 square plus 70 square plus 45 square. And so you will get some value into I plus some value into Z plus some value into K. You will have to divide it individually. And so FOG bar will be magnitude of OG, which is 200 into OG cap. And so you will again get some answer as I, J, K. So FOG bar can be found out. After FOG bar, we will be finding FDG bar. That is, first of all find out DG bar, which is G bar minus D bar. G bar is 30I plus 70J plus 45K minus coordinates of point D are 0, 0, 45, that is 0I plus 0J plus 45K. And so this comes out to be 30I plus 70J. Mod of DG bar, or if we find DG cap directly, it will be 30I plus 70J upon under root of 30 square plus 70 square, which will be some value into I plus some value into J. And therefore FDG bar will be magnitude, that is 150 into DG cap. So it will be some value I plus some value J. So ultimately we have got FBG bar, we have got FOG bar, and we have got FDG bar. These three values we should take and substitute in this, and you will be getting some answer as something into I plus something into J plus something into K. That itself is the required answer. That is the resultant force at point G. Resultant force at point G. Almost all the problems will have the same procedure. Almost all the problems will have the similar procedure. Let us consider another problem where we are given some pole which is supported by the guy wires. Now guy wires are the cables which are connected to the top of the pole and then attached to the ground, and by applying the proper tension, that particular pole can be held in the vertical direction. And now the guy wires which are attached are like this. So one cable which is attached like this, another cable has been attached in this manner, and the third cable has been attached over here. So this is O. These three supports are A, B, C. This is point P. It is given that tension in AP is 1200 newtons. Find tensions in BP and CP. Also find resultant force at P. Also find resultant force at P. and we are also given the distances in meters. This is 15 meter, this is 30 meters, this distance is given to us as 50 meters, this is given to us as 12 meters, and this is 20 meters. The height of the pole is also specified as 60 meters. So all the dimensions are given to us. Now remember that these are all cables. These are all the cables which are attached to the pole at point P, and obviously they will be giving a pulling effect. So the tensions can be shown in this direction. So their effect will be like this. So call it as T1, T2 and T3. So the net force at P, should be equal to T1 bar plus T2 bar, or instead of writing it as T1 bar, T2 bar, let us write it as tension in PA bar plus tension in PB bar plus tension in PC bar. Now also the fact remains that the purpose of the guy wires is to hold this particular pole in the vertical direction. So the resultant force at P must have the direction along Z axis, that too downward. There should not be any component along X axis or Y axis. So we will also say that the resultant cannot have X or Y component. Resultant cannot have X or Y component. So ultimately net force at P, will have only the K component. That means it is to be written as 0I plus 0J plus some K. Now this is overall thinking behind it. Now let us represent each of these, because what we are given is T1 as 1200, T2 is to be found out, T3 is to be found out, and then net force at P, so resultant at P is to be found out. This is what the problem statement is. So let us first of all write down the coordinates of all the points which are coming into picture. So coordinate of point A. Now along X axis you will have to measure the distance parallel to X axis. X coordinate of point A will be 30. This is positive Y direction. We have distance 15, but it is measured from O in the opposite direction. So Y coordinate of A will be minus 15, and being in XOY plane, Z is 0. For point B it is simple, because X coordinate will be 12, Y coordinate is 50, Z is 0. Whereas point C is on X axis but in the opposite direction, so it is minus 20, 0, 0. And point P is on Z axis, so it is 0, 0, 60. Once we get the coordinates, then we can proceed even in the columns manner or a tabular form, because now I can write down vector PA bar. Vector PA bar can be found out because it will be A bar minus P bar. A bar is 30I minus 15J plus 0K minus P bar is 0i plus 0j plus 60k. So ultimately PA bar comes out to be 30i minus 15j minus 60k, and so you can find out PA cap, that is vector upon magnitude. Once we find PA cap, then TPA bar will be T1 into PA cap, and T1 is known to us, so it is 1200 into PA cap. That is our first calculation. Then to find PB bar, it will be B bar minus P bar. B has got coordinates as 12i plus 50j plus 0k minus it is 60k. So ultimately it is 12i plus 50j minus 60k. Find out PB cap, and then TPB bar will be T2 into PB cap. Of course, here all the terms will be something into T2i plus something into T2j plus something into T2k. This is how the term will appear. So we get TPB bar, and then we can proceed to find PC bar. Coordinates of C are minus 20i and that of P are 60k, so minus 20i minus 60k. So we can find out PC cap, and then TPC bar will be T3 into PC cap. So it will be something into T3i plus something into T3k. So we got the three answers. This is one. We have got TPA bar and we also have got TPC bar. Now these three are to be added, and so we can write it as resultant at P, RP bar equal to TPA bar plus TPC bar, PB bar plus TPC bar, and so you will get some equation over here, because there will be some term of T2, there will be some term of T3i. Then probably TPC doesn't contain J term, so there will be some term of T3 here, J, and some other terms also could be there. And finally you have some term plus some term into T2 plus some term into T3k. And so resultant force at P, after adding these three forces that we have calculated in the vector form, we are still not getting the answer because it is still containing the unknowns T2 and T3. But remember that we have already said that this is going to have only the k component. That means this first coefficient, this should be equated to 0. The second coefficient of J should also be equated to 0. And ultimately you will get some equation from I, that is equating coefficient of I to 0, we get one equation, and similarly equating coefficient of J to 0, you will get some equation like this. There will be a term of T3. T3 doesn't have J. So from this second equation, actually we are required to solve these two simultaneously, but as there is no T2 in the second equation, we will directly get T3 from here, which we can substitute in the earlier equation and find out T2. So out of the required answers, we will get T2 and T3. And now if we go back to RP, then RP has got some term plus some term into T2 plus some term into T3, K. Just substitute these two values and you will get the numerical answer for resultant force at P. So problems are rather simpler in this case, as long as we are into the area of equilibrium and the concurrent forces. Of course, these are all the cases of concurrent forces only. Another type of problem in this case will look like this. Some load W is supported by the supports as they are shown here. For one support, figure has to be understood properly, otherwise there will be lot of difficulties while solving the problem. So observe that some weight is supported by 3 cables which are attached to the ceiling. Say this is point A, point B, point C, and the distances are given to us as 10, 40, this is 20, 20, this is 30 and 5. And the weight is suspended at a distance equal to 50. We will be given the value of weight, which is say 2000 newtons, and we are required to find tensions in all cables. Tensions in all the cables. What is important in this case is first of all writing the coordinates, and then the job will be very simple and straightforward. Let us write down the coordinates of all the points. Let us call this particular point as point P. A has got coordinates. Along X it is 40 and along Y it is 10. So coordinates of point A are 40, 10, 0. That of point B, you will find that along X it is going in the opposite direction, so minus 20, along Y it is 20, then 0. And for point C, along X it is opposite direction, so minus 5, along Y again minus direction, so minus 5, minus 30, 0. And point P is in the negative Z direction, so it will be 0, 0, minus 50. So we could write all the coordinates. Now the procedure or the steps for solving the problem. One by one I am telling you. First step is to find out, because now the weight will be supported by the tensions which are acting in this manner. Weight will be supported by the tensions which are acting from P towards A, towards B and towards C. So let us assume the tensions to be T1, T2 and T3 respectively, PA bar, PB bar and PC bar. So first step will be to find out PA bar, PB bar, PC bar, which we can very well find out. Step number 2 will be to find out unit vectors PA cap, PB cap, PC cap. Third step will be to write down tension PA bar, which will be obviously T1 into PA bar, PA cap. PB bar will be T2 into PB cap, and PC bar will be T3 into PC cap. But net force at P is 0. So when we consider summation of all the forces, that is T PA bar plus T PB bar plus T PC bar minus WK, because it is acting in the downward direction, should be equal to 0. So we have got T PA bar in terms of Ijk, that is in terms of T1. We have T PB bar which is in terms of T2. We have T PC bar which is in terms of T3 minus 2000 K equal to 0. And ultimately you will get one equation which contains the terms of T1, T2, T3, I, plus second equation which contains the terms of T1, then T2, then T3, Z. Then one more equation, T1 plus T2 plus T3 minus 2000 K equal to 0. So you will have to equate each one of them to 0. You will get three equations, 1, 2 and 3. Three equations in terms of T1, T2, T3. This is actually the first equation, this is second equation, this is third. Solve simultaneously to get T1, T2 and T3. Solve simultaneously to get T1, T2 and T3. And so the problem becomes the solvable one. This procedure is generally applicable for all the problems in 3D. Next part in 3D is to consider the moment of a force. Now moment we have defined it as the force into perpendicular distance, and in 2D we had the sense as clockwise or anti-clockwise. But in 3D we cannot first of all use these wordings clockwise or anti-clockwise, and secondly the moment will not be found in the sense as force into the perpendicular distance, because to find a perpendicular distance there will be a lot of trouble. Instead of that we will take help of the cross product, because moment of a force about a point, remember that whenever we have a force whose moment is to be taken about a point, then the force will be fully defined by the 2 points, that is the line of action of that force, and the point about which we want to take the moment. When these 3 points come together, they are going to form a triangle which is a stable plane. So the force and a point together will be forming a plane which is a 2D problem type of thing, and then we are required to drop a perpendicular from the point onto that particular force and then take the moment. But that moment is going to be always perpendicular to the plane in which the force as well as point reside. Now this perpendicular sense is obtained through the cross product. So in 3D, when we talk of the moment, then moment of force F bar, moment of force say F AB bar about point C, about point C. So the pictorially it will be shown like force from point A to point B, and this is point C. We want to take moment about this point. Then remember that this moment will be written as R bar cross F bar, and for R bar it will be from the point about which we want to take the moment, draw a vector to any point on the force, either point A or point B or any point for that matter. So in this case it will be OA bar cross FAB bar, not OA bar, CA bar cross FAB bar, or this can also be equal to CB bar cross FAB bar. Now of course for the cross product you will be requiring the formulation as, suppose if P bar is P1I plus P2J plus P3K and Q bar is Q1I plus Q2J plus Q3K, then P bar cross Q bar in vector notation form is determinant Ijk, first the coefficients of the first vector as second row P1, P2, P3, and then coefficients of the second vector Q1, Q2, Q3. This is the base by which the moment can be taken. Actually this is the base for taking the cross product, and we will be getting the answer also in terms of Ijk. Expansion, you are aware that it is P2 Q3 minus Q2 P3 I minus P1 Q3 minus Q1 P3 J plus P1 Q2 minus Q1 P2 K. This is how the answer can be obtained. So in the exam we might have some problem where they will ask us to find the moment of a force about some point or about some line. Moment of a force about some point or some line. So this is moment about a point. Once we get this moment vector, then it can be projected on some other line. Moment about line, say PQ. If that is to be found out, then we will say that find moment of the force about P. Find MP bar, and then project MP bar along PQ bar. Project MP bar along PQ bar, and projection has got a formula like this. Suppose vector R bar is to be projected along some line, say L bar, then the projection will be this part. This is called as the projection of R bar along L bar. Now we are knowing the fact that this is going to be distance wise R cos theta. So actually this is R cos theta. But r cos theta can also be written as r into L into cos theta upon L, and RL cos theta is nothing but r bar dot L bar upon L. See, we are just dropping a perpendicular from the tip onto that line, so we can obtain the projection. So this was the length of the projection of r bar along L bar. So that length will be, obviously, if r is the magnitude, it will be r cos theta. So it will be r into L into cos theta. I am just multiplying by L in the numerator denominator. So it will be r bar dot L bar upon L, which is r bar dot L cap. So this is going to be the formulation for the projection. And so project MP bar along PQ bar, when we say project MP bar along PQ bar, that is moment about line PQ will be MP bar dot PQ cap. That will be the required answer. Of course, this answer is going to be the scalar one, not the vector, whereas MP bar is a vector. So we will be following these steps for finding the moment about some line. If it is moment about a point, the job is simple and straightforward. So let us have a look at the problem which is to be solved for finding the moment. So we are given some triangular prism. Of course, the triangle is not a regular one, it's a right angle triangle. The distances are given to us as 12, 10 and 18. So these are the distances, and the forces are acting first of all from D to B. So there is a force acting from D to B, F1. Then there is a force which is acting from C to A, which is F2. And there is a force acting from O to E, F3. This distance was 18. It is given that F1 is equal to 500 newtons, F2 is equal to 300 newtons, and F3 as 400 newtons. Find the resultant force at point O along with the moment. This is first part. Second part, find moment of F1, find moment of F1 along CE. Find moment of F1 along CE. So this is the type of problem that we have. Now F1 is acting from D to B. F2 is acting from C to A. And F3 is acting from O to E. From the dimensions which are given to us, let us first of all write down the coordinates so the problem can be solved. Coordinates of point A will be obviously 12, 0, 0. That of point B are 0, 18, 0. Of point D will be 12, 0, 10. Of point C it will be 0, 0, 10. And point E will be 0, 18, 10. So we could easily find out all the coordinates. Procedure will be first to find out all the vectors. That is, find out dB bar, which can be directly written as coordinates of D. It is from D to B, coordinates of B minus coordinates of D. So it will be minus 12y plus 18z minus 10k. That is dB bar. Then write down CA bar. So coordinates of A minus C, it will be 12y plus 0z minus 10k. And then OE bar, which will be 0i plus 18z plus 10k. Obviously next step will be to find out dB cap, CA cap, OE cap. And then write down F1 bar, which will be 500 into dB cap. Find out F2 bar, which is 300 into CA cap. Find out F3 bar, which is 400 into OE cap. into OE cap. Now if I simply write these vectors as F1xi plus F1yz plus F1zk values you have. This is F2xi plus F2yz plus F2zk, and then this is F3xi plus F3yz plus F3zk. These values are known to us, of course. Therefore we can say that net force at P, net force at O, so force at O will be F1 bar plus F2 bar plus F3 bar, and we can very well get the answer as something Izk. So this answer can be obtained. Now to find the moment at O, we will say M1O bar. To find the moment of force F1 bar about origin. So F1 bar is a force which is acting from D to B. So we can write it as OD bar cross F1 bar. And so it will be the determinant Izk. OD bar will be 12, 0, 10. And this is F1x, F1y and F1z. and so we can get the answer in ijk form. Similarly, moment of second force about origin F2. F2 is acting from C to A. F2 is acting from C to A, and so we can consider it as OC bar cross F2 bar. Coordinates of point C are 0, 0, 10. So it will be determinant ijk 0, 0, 10, and it will be F2x, F2y and F2z, and you will get the answer in terms of ijk. Probably k term will turn out to be 0. Whereas moment of the third force about origin will be simply 0, it is still passing through origin. F3 is OE bar, along OE bar it passes through origin, and therefore net moment about origin will be moment of first force about origin plus moment of second force about origin plus moment of third force about origin, and you will get final answer again in terms of I, J and K format. So rather a procedural problem once you get the coordinates. Even if the moment is to be taken, we can always use the cross product, and that will be easier. We don't have to bother about finding the perpendicular distance. That was the first part of the problem, that is to find the resultant force at origin along with the moment. So we have got resultant force, we have got the resultant moment at origin. In the second part it is said that find moment of F1 along CE. Find moment of F1 bar along the line CE bar. Now see, force F1 bar is from D to B. This is the force and this is the line. It is going to have some effect of rotation about line CE bar. But we cannot find moment about a line. Instead of that, we will go for moment of F1 about point C. If moment of F1 about point C is to be calculated, we will have to have some r bar vector from C to B, or B we can draw one line. In this case I am joining it to D. So it will be CD bar cross F1 bar, and so it becomes a determinant I, J, K. CD bar means D minus C, so it will be 12i plus 0j plus 0k, 10 minus 10, and F1 we know the coefficients F1x, F1y and F1z. In this case there will not be any I component, there will be some j and some k. I will turn out to be 0. Once we find moment about C, then let us find out CE bar. Now CE bar in this case comes out to be E minus C, that is 0i plus 18j plus 0k. So CE bar comes out to be 18j. CE bar comes out to be 18j. Then find out CE cap, which will be simply j. And as per our formula, moment about line CE, moment about line CE will be equal to moment about point C dot CE cap. And we have already calculated moment about point C. Dot CE cap means dot J. And so it will be simply, if I call this as C1 and this as C2, the answer is going out to be only C1. This is the second part of that particular problem. You will have to take the moment about any point on that line and then project it on that particular line. If you are projecting the vector on to a particular line, then that original vector will remain as it is, and the second vector should be considered as unit vector, and we will be taking the dot product. This is how the problem is to be solved. Of course, the moment of the force about origin that we have calculated, when we have calculated the moment about origin, it contains something into I plus something into j plus something into k. Actually, coefficient of I is nothing but the moment of the force about x-axis, because when you want to find the moment of the force about x-axis, you are required to take the dot product with I, and any vector dot I will be only the coefficient of I. So moment vector that we have found out in terms of I, j, k, over there coefficient of I is nothing but moment of that particular force about x-axis. Coefficient of j is nothing but moment of the force about y-axis, and coefficient of k is nothing but moment of the force about z-axis. Now with these basic problems, actually we don't have in-depth problems for the 3D. Even if you have understood these basic problems of 3D, probably one, that is 8 marks to 12 marks problem, we can always attempt in the final exam.